performance is a really, really important thing because it can bring in revenue and things like that. I'm not going to delve too much into this topic today. There's a great little link on the bottom of here by Harry Roberts, who's another local Leeds lad. These slides are available online. There's a link at the end. I've also tweeted it. So if you just look at Ryan Townsend on Twitter, then you'll see that. So he's done a great talk on why you should be caring about performance. So I'm just going to give you a quick little kind of intro from a retailer's perspective as why this matters. So if you're an online retailer, or any retailer really, you have a portion of traffic, whether that be to a store or whether that be to a website, people coming to you to come and buy stuff. A portion of those people will convert into actually placing an order, and then you'll have an average order value, or AOV, across all those orders. So if you improve any of those areas, then you improve your overall revenue. So this is basically the calculation. It's fairly straightforward. When it comes to performance, we can improve traffic vastly with performance. So Pinterest did a rebuild around improving their performance and saw that they increased their traffic just coming from natural organic search engine rankings by 15%. Google have kind of backed this up. They've said, they've been ranking sites based on their performance for a while. But what you may not be aware of is until July this year, it was only on desktop searches, and then now they've introduced it for mobile searches as well. So if you're on your mobile device, performance is actually factored into that ranking now as well. So it's becoming more and more of an important thing. Performance can also improve your conversion rates. So another kind of testimonial, Mobify are a big company in the States. They've got a lot of big retailers and big companies under their belt. They found across their user base, if they just chopped off 100 milliseconds, a tenth of a second, off just the home page, they saw over 1% uplift in conversion, which meant an extra revenue of $376,000 a year. Obviously, there were some pretty big companies. If they did the same thing during a checkout process or some sort of purchasing flow, they saw an even greater uplift of over 1.5%, amounting to over $500,000 a year. So conversion can be affected by this as well. And then finally, for average order value, no one's kind of directly really studied this stuff, but I've looked into some of the stats from our clients, and we found that it actually correlates quite heavily with the amount of pages people view. So they're absorbing far more content on your site, maybe seeing more products that are related, are useful to them. So they're going to build bigger baskets of stuff that they want to buy from you. And this is the correlation. So it was, just about a percentage out in terms of the average order value after improving some performance. So ultimately, performance is great because it improves all of these areas and you get the multiplier effect of your revenue just increasing off the back of it. But the reason why I'm here today is because it's not as simple as just saying that to people and saying, hey, yeah, we should invest some money in web performance. It's quite a tricky thing to get over to people and for people to believe. They see these fancy big numbers and think, oh, well, yeah, that's that company, but how does that really relate to us? You can see how difficult it is based on this image. So this is an image that's in an article that I'm writing at the moment. It's not published yet. These are some of the top 44 retailers in the UK. Shoe is the top one. They're one of the fastest retail sites that we have. This is when they are completely loaded in terms of their viewport and the status of the rest of the industry and their competitors as they get to fully loaded. You can see all these retailers down here haven't even shown anything at the point Shoe is completely loaded. So it's quite an outstanding effect. You can see that these people aren't generally investing that heavily in web performance. They may not have that visibility. So we want to try and help that. So rather than trying to discuss how we kind of sell it into people, which can be that challenge, what I want to look at today is what can we do without the permission? What can we build fast websites without needing to go and get sign off and budget and all these other things? What little things can we do? You might need permission to build the absolute fastest websites on the planet, where you're changing your DNS providers and implementing new CDNs and all this kind of fancy stuff. But you can get pretty far without having to do anything too fancy. So this is one of the kind of most famous quotes ever and one of my favorites, which is it's easier to ask for forgiveness than to get permission. So I think that's a good way to start this stuff. So before we dive into kind of optimizing sites, there's a few things that we need to kind of take care of. So the first one is that we actually need to monitor and measure this stuff. You need to know what your starting point is and then whether you've actually affected this positively or negatively. So I'll be showing a few tools that you can run just kind of against any website, but kind of the continual monitoring side of things. We use a tool called SpeedCurve. They offer synthetic testing where it pulls a site every few hours or on whatever schedule you set. It'll do it from different devices, different network profiles. You can see these are all the retail, well, it's pretty small, but you can see these are all the retailers that are on that previous image, and that's how I produced that image. So we monitor all of their performance on a regular basis, and it will literally test things like Google Chrome on a desktop connection, an iPad on 4G and an iPhone on 3G, but you can kind of set up whatever profile you want. And then the second part of this is actually understanding what kind of users do you have. Do you have a high portion of desktop users, a high portion of mobile users? Because it'll depend on what techniques you want to apply. And also, what kind of browsers are they using? What kind of technology are they using? New phones and new devices, or are they using older ones? This is a chart from one of our clients, so you can see the drop-off in IE9. If you're implementing a new project, yes, you might have a high portion of an older browser now, but by the time it actually goes live, if it's a big project that takes 6 months, a year, you might not need to worry about that browser anymore. So what you implement in terms of anything cross-browser, but also the performance side of things, may vary depending on the way that the market's going. So I couldn't start just tearing apart clients' websites and undoing the work that we've done to optimize them to kind of produce this talk. So what I've done is I've produced a sample project called the slowest site in the world. It's a bit kind of hyperbolic. It's not actually the slowest. It's just kind of got a few things that make it pretty slow. This is an open source GitHub project, so you can use it as kind of an example and to try out new techniques or train members of your team up. So that's just available on GitHub. And there's a little button at the bottom that just allows you to deploy it into Heroku. It's completely free. You can just use a free account. So that way you've got like a public version of this live. It just helps you deploy it really quickly. So as I go through this talk, what I'm going to be doing is kind of taking the slowest site in the world, applying a bunch of optimizations to it, and then spitting out the results of that. So the way that I'm doing that is using web page tests. This is a public website, you can go to it, and this actually is the simplified form. So if you just go to /easy, the URL is just up there in the corner. You can put in any domain name, pick really easy, slow 3G on a mobile, regular 3G on a mobile, tablet on 4G, and I think there's a desktop one in there as well. So you can kind of run these tests. I've set it to, it says slow 3G there, but I've set these results to regular 3G because it's a bit more kind of average. Not everyone's on the slowest connection in the world. And it was that slow that it was taking too long to produce the results, so I was getting a bit bored sitting around waiting for them. So the initial results of the site are pretty bad. If anyone's done any web performance testing, this metric's pretty bad. So 6.5 seconds before you see anything at all, it's just a white screen loading. Speed index shows you how much of the site is loading it over time. So you want to get that as a low value as possible because that means more content's getting in there sooner. So this is pretty bad. Time to interactive, so this is the more JavaScript side of things. This actually becomes interactive before it's even shown anything on the screen, and that's how bad the start render time is. But even still, we're waiting 4.5 seconds before we can scroll and we can interact with the actual content. And then we're using 2.5 megabytes of bandwidth there as well. So for anyone who's on a capped data plan, still there's a high portion of people, even in the UK on pay-as-you-go and things like that, they're literally paying for every kilobyte you send. We shouldn't just be abusing their data plans, so we need to work on that as well. So obviously this is a bunch of stats, but it doesn't really kind of give a good feeling of what it's like. 6.5 seconds is actually a long time. So I've taken the recording. Again, this is just produced out of web page tests, so you can see these if you run it through your own site. So I'll show you how slow 6.5 seconds feels when you actually run it. So 3, 2, 1. It's pretty bad, right? And then we've got so most of the site comes in all at once, and then we've got this enormous photo of Leeds, which I've been doing my bit for tourism, going around the world, giving this talk and kind of showing off Leeds in the mid-time. But yeah, so we don't really care too much about when it actually finishes, but it was a pretty bad experience. So that's our kind of starting point. And you can tinker with this stuff as you're going through. That for some reason hasn't updated. There we go. You can tinker with this stuff as you go through if you want to just play around with your site, tweak a few things. In Chrome DevTools, you have a thing called local overrides. This allows you to literally copy down a file, edit it locally, save it on your machine, and then when you reload in the browser, it load the one off your machine instead of the one remotely. So you can play around with your HTML, play around with your CSS and all that kind of stuff without actually publishing anything. So that's just a quick tip for trying some of these things out. So we've actually got to the optimization section now. I'm going to have to be very quick because this talk usually takes 40 minutes and I know I've only got 30. So we're going to start with kind of the connection side of things and go down how a website loads. So we need the HTML first, then styling usually happens and we're pulling in Webfonts as part of our CSS, JavaScript, and then images kind of happens asynchronously afterwards. So we're just going to go down the traditional way of loading a website. So the connection one, I'm kind of breaking my own rule already because we said we weren't going to be looking at infrastructure and all that kind of technical stuff. But effectively, if you've got stuff in place and there's features that aren't turned on, it's worthwhile getting to know your operations team or whoever runs your infrastructure and just asking them, you know, can we enable broadleaf compression or just check that gzip's enabled? Can we get OCSP stapling for our SSL so we're not doing a round trip to another provider when you connect? HTTP2, if you can turn that on, will just give you 30% faster website overnight. Literally, it's just as easy as that. And then this one's a bit kind of esoteric. Some people, I've seen two cases where someone was sending a connection close header on every file they were sending, which then means the browser has to reconnect for every single file, do a whole, you know, new TLS connection and all this kind of stuff, every single file. So just check that it's still set to keep alive, basically. So I haven't done a before and after for this one because it's stuff that, you know, you would actually, you know, maybe have to get permission for. But I just wanted to raise that there's a few things that we can just check up front and may just be a checkbox in someone's admin panel somewhere to enable them. So I'm going to go onto the HTML and we're actually going to specifically just talk about the head tag. Now you might not believe this, but actually the ordering of the tags within your head tag actually will make your site faster or slower depending on what that order is. So again, Harry Roberts has done a bit of analysis on this stuff and found the most optimal order for this. He hasn't published it yet. I was trying to get him to publish it before today, but he's given us the preview. So first of all, getting your character encoding because your browser has to kind of figure that stuff out. It doesn't want to have to go back and reparse everything in UTF-8 after you've told it to. Get your viewport set up correctly, so you know what size is the screen. Your title tags, so as soon as possible you get something that shows your website's loading rather than just literally the word loading at the top. Resource hints I'll come on to, that's just to help speed up the website and give hints to the browser to say, hey, you're going to need this file in the next couple of seconds, go away and get it now. Any inline scripts, so literally a block of script tag with the actual contents inside, an external style sheet, so whether that be first party or third party, just a file for your style sheet link tags. Any inline styles, external script tags, and then just literally all the rest, all your social stuff, Facebook, OG tags and all that kind of good stuff. So just dump the rest at the bottom. So I mentioned resource hints. These are quite cool because you can give hints to the browser about stuff that it's going to need up front rather than waiting for it to discover things further down the line. There's actually another one, so there's 5 in total, I think. But there's one that's kind of in flux, so I've left that out just to make it a little clearer. So I think the original one was DNS prefetch. And what that does is just say, hey, you're going to need to use a domain at some point. So just go and do the DNS lookup now, because then we don't have to wait until we need that file to then do that lookup. That's then been superseded pretty much by pre-connect, because if you know that you're going to need a domain, you're probably going to be connecting to it. So pre-connect kind of follows on from that. So that's great for somewhere where you know the domain, but you don't know the specific URL. Or you might have like a CDN that serves your imagery, and it's got 10 different files. You don't want to preload them all. You just want to say, hey, we're going to be connecting to this CDN at some point. So connect to that now. Preload, that literally says download this file and put it into the cache because you're going to need it in a couple of seconds. So that's great for kind of nested content that needs to be discovered. So if you've got a CSS file that's loading in a bunch of font files, you can say, hey, here's some font files, you're going to need them, even though the browser doesn't know until it's got that CSS yet. And then prefetch is basically the same as preload, but it's just low priority and happens after the page is loaded. So if you think that there's going to be kind of a follow-on request, maybe the next page someone views, you can set that up for use with prefetch. So to kind of visualize what this means, this is a waterfall chart just out of web page test. We've got up here we've got a CSS file that loads in some fonts, and then down here we've got the actual fonts being downloaded by Google. So we may not be able to preload this request because it's Google's font files and they might change the URLs at whim, but we know it's always going to be fonts.gstatic.com. So we can go away and say, look, pre-connect to that, and then this time here, where it's doing a DNS lookup, initiating the connection and doing SSL negotiation, it can do that right here, and then we don't have to wait those, well, it's over a second on this chart. We don't have to wait over a second there to download that file. We've already got that connection ready. In terms of support for this stuff, pre-connect is pretty well supported now. It's 80% of browsers in the UK. This is something that is a progressive enhancement, so you can add it to your site. It's not going to damage the 20% that can't use it, they'll just simply ignore it. And what you can do is actually combine that link tag with the DNS prefetch as well. So for the browsers that don't yet support the pre-connect, well, they never will because it's Internet Explorer, basically. It'll give that benefit, a little bit of that benefit to those as well. So you can literally just space separate them within the rel attribute. And then preload as well, 77% support, so really, really solid stuff now. I've had to update this talk about 10 times this year because every single time, a new release comes out of a browser and then it changes the stats all the time. So the results of this are pretty outstanding. We've chopped 1.8 seconds off our start render time. I've used the Mobify case study from before to kind of calculate the value of this to their clients. It's a lot of money. For some reason, speed index went up. I've not gone back and figured out why yet, but I need to at some point. I think it might just be that we were choking the network a bit as part of that kind of initial load. It all gets improved at the end when we combine all of these things together anyway. So next up, we've got CSS. So we downloaded our HTML. Now we need to go away and style it. First thing, just remove at import. It's that nested thing of like, I've downloaded my CSS file. Now I've discovered I need another CSS file, or I need some fonts, or I need these other assets from the CSS. It's fine for imagery because that doesn't block, but generally your fonts and other style sheets will. So you need to kind of inline all that stuff into one file or a few files that you serve from your HTML and not using at import. Effectively, this is twice as bad, or maybe more, if you're using a third-party import as well. So if just say you've got your own style sheet, but then you've got a Google style sheet or something like that embedded within yours, because effectively what will happen is you're handing over control of your performance, of your uptime, and your security to that third party. Now, hopefully you can trust Google, but ultimately, even Amazon has outages and things like that, so that could take your site down. Because your browser's going to wait until it gets that CSS file to be able to render anything. We've also seen things like keyloggers being built in CSS these days, so like security can be an issue. You've also got the whole GDPR thing of like, oh, well, we've just embedded a CSS file. Well, now we need to tell people that Google could be like recording their activity on the site because we've now got a CSS file loaded from them. So if you just serve that stuff yourself, it's far easier. Then you get the opportunity to kind of inline the critical CSS. So that's the CSS that takes to render that initial viewport above the fold. There's a load of fancy tools that does this. I think there's a library on NPM called Critical that does it. But if you want a really simple way of just checking the kind of benefit, you can go into, again, Google DevTools, and they have a coverage checker. So you can see the little green bars here, that's CSS that is being used, and then the red bars are CSS that aren't. And you can see like percentages, how many bytes are wasted and all this kind of stuff at the bottom. So you can browse around your site and record this usage, and then find that certain selectors may not be being used, or at least above the fold, and then just output that into an inline tag. And then the rest you just want to load asynchronously from a file beneath the fold effectively. So if we implement this, we don't really have much of an impact here. I mean, it's still a lot of money to Mobify customers, but not as impressive as the last one. But this is when the site's operating properly. This site had Google fonts on it, so if Google had an outage, this would happen. you have 90 seconds the browser will wait until it gives up on a file. And currently you can't control this. So if that was out for a year, 339 million would be lost. Obviously this number's ridiculous. So it couldn't even calculate the speed index, it just gave up. So you've effectively handed over that uptime to Google. Now, it's very unlikely that Google's going to be offline for an entire year, or that you wouldn't fix the site in that time either. So a more reasonable figure might be $38,000 in an hour. You know, if you're serving a big site, that's a lot of money to just disappear in a short space of time. So we've kind of been chatting about the Google Webfonts stuff, so we can delve into this a little deeper now. Again, self-host this stuff. There's a little link down here. If you're using Google Fonts specifically, this is a real awesome little tool that will help you download those. So you just put in the name of the font and it'll give you a zip file. The next one is a new attribute that's come out basically this year. I think it's been in development for a while, but the actual adoption by browsers has really skyrocketed. I think the first version of this talk I gave, it was at 20% compatibility, and now it's far greater than that. So font display, you put in the font face declaration and you say, how do you want to load this font? Optional will effectively say, download the font, but don't render it on the first page view, just use the fallback fonts. So use whatever's built into the browser or the operating system. Swap will say, okay, download it and wait for, say, 3 seconds. It's up to the browsers to kind of decide what that period is. And if it doesn't appear in that time, if they're on a really slow connection or if there's some sort of problem with that download, effectively don't bother, just, again, leave it optional effectively, but try and get that font to that person. So depending on kind of your use case, you will use either of these. For a lot of websites, you can get away with using optional. If it's a traditional one where someone's literally clicking links and browsing around. But if you've got a lot of Ajax, or if you're building a single page app, you don't ever get that second page view. So you'll need to use swap for that effectively, because you need that font file to be replaced in. The downside to that is that you do get that kind of flickering, that re-rendering as that font file loads. So you do get a bit more of an impact to the user journey, the user experience with that. But it'll just, again, depend on your usage. So I mentioned that this has vastly increased in support, so we're now up to 77%. Again, it's progressive enhancement, so you can just drop this in and new browsers are going to get a lot faster, old browsers won't go backwards. Similarly to things like images, we serve the correct type. WAF2 has been out for ages now, so this hopefully isn't too new, but effectively it's a 30% decrease in the actual file size. So you're just sending fewer bytes over the wire. It's got pretty solid support at 88%, and then you just serve WAF1 to the older browsers. So I think IE 9 to 11 supports WAF1, and you can just do that as part of the declaration. And then the final tip for fonts is to use unicode-range. This is effectively bundling, but for web fonts. So you just specify a range of characters that appear in a file, and then the browser will download whichever files it needs based on what characters are on the page. So if you've got most of your content in just kind of standard English with no accents and things like that, you can make a font file that's just those, and then you could have a file with all the accented characters in them, and then only download that on the pages that actually use those characters. So again, you're only sending the bytes of data that you actually need for that page. So what I did is just take the Google style sheet that's provided by that little helper that downloads it for you. All I've done to alter it was literally change the URL to point to my local image file, and added font display swap along the bottom of here. All of the Unicode range is already provided by Google, so that's great for us if you're using that. But it's fairly straightforward. There's a bunch of tools that you can use. I can't remember the name of them. I don't have them in my notes either. That allow you to create subsets and things like that. So I will do a bit of Googling and find out what those are. So if you need to do this manually with your own fonts, then you can do that as well. So when it comes to the results, pretty solid. We've chopped off 1.8 seconds just through optimizing fonts. And again, a load of money. So great for big companies. This is where it starts to get a bit tricky, is JavaScript, because I'm sure that everyone in the room uses different frameworks, different build pipelines and all this kind of crazy stuff. So there's a few tips that I can kind of give in kind of generic, generic formats that will help kind of any system. So the first of that is just how you download your JavaScript. So by default, annoyingly, browsers decided that synchronous was going to be the way. So that will literally block the download of your web page. Obviously, you can put this stuff at the kind of end of the body tag, but effectively, you want to get that discovered as soon as possible by the browser and get it downloaded so you can start to get the site interactive. So try and avoid synchronous as much as possible. Async you can just drop in as an attribute. And then we have defer, and defer is not widely used. It's actually predates async as well. It was in IE5, so it's really old, but it's still valuable today because effectively there's kind of a good diagram here from Google which kind of explains how they operate. So you've got your HTML parser, which is this green bar on the bottom, with a standard script. What it does is it goes away to the network and just stops the parser at that point. It says, well, look, we're not going to look further for any more kind of HTML. Downloads the file, executes it, and then returns to parsing. So the trouble with that is obviously you're not discovering, not getting further down the path of your HTML. If that's in the head, you're blocking all your rendering. With defer, what it'll do is it'll download asynchronously, but then it'll wait until the complete page load before it actually executes. So that's great for things that aren't that important. Maybe you want something like your some sort of analytical tools or remarketing things where if it doesn't fire, then yeah, it's a bit annoying, but it's not the end of the world. And with async, it'll download asynchronously, but then as soon as the file arrives, it's going to start executing it. So you need to be mindful of files that are quite small over async may actually interrupt that flow of you loading that web page. It may be better for things to execute further down the line. So, standard thing that people say when you're downloading JavaScript libraries is to use a CDN. This means two things, I think. Some people it means, yeah, use Fastly, use Cloudflare, use CloudFront, whatever it may be, different providers. Make sure you're hosting it somewhere that's globally distributed so it's nice and fast to download. I agree with that when it's a case of something that looks like this and it's Cloudflare or Google or whomever. This is something that you probably want to avoid. It goes back to that whole thing of handing over the control of your site to third parties. This could get hacked at some point, hopefully with Cloudflare or Google. That's not going to be the case, but these things happen. But also, the main reason people cite for doing this is that, someone else's site will have had jQuery on it already. That means that it'll already be sat there in the cache. It's not always true. In fact, for Safari, it's never true. Because of privacy reasons, they want to make sure that each site is kind of isolated. So even the cache of third-party assets is isolated to your site. So no one on Safari gets the benefit of you using the same version of Safari as another website. So it's never in cache for them anyway. So they just pay the penalty of another DNS lookup, another TLS connection, and then you've got to download that file. And it makes your whole build process a little more complex. So just serve this yourself. Again, the chances of someone having the same file as your site on theirs, there's a billion different versions of jQuery. It's just not going to happen. So just host this stuff yourself, and you won't pay that hit. JavaScript is not just about that download time either. This is again where it gets a bit more complex. So you have, once it's downloaded, the browser's got to parse that and actually compile it into code that it can run and then execute that code. So I can't go into any detail here because it'll depend whether you're using Angular or React or Vue or any other. So just make sure that you're doing some form of bundling to make sure you output the optimized JavaScript files, and tree shape to remove any dead weight from those bundles as well, and try and get them as small as possible. Less JavaScript generally is going to execute quicker and download quicker. So the results of this, we haven't really changed any start render time or speed index, but our time to interactive is far faster now. I've got like less than no time. So I'm going to go really quickly through images. Foreground and background images, you may not appreciate that these two things are actually treated very differently by browsers. It's fairly simple stuff. You know, you've got an image that's with a tag, that's a foreground image, and then you've got your CSS for background images. These are actually prioritized completely differently by browsers. So browsers think, oh, well, it's background, yeah, it's not important. You probably have a background color as a backup for while that's downloading. But images that are foreground, it's like, this is the content, we need to get that in front of people as soon as possible. So if you have scenarios where maybe you're using, is that a countdown? Where you're using a background image where you should use a foreground image, you can end up with things like this. So that hero image that we have, that big photograph of Leeds, is actually the last image to download because it was set to be using a background image. Whereas we had all these other images that were loaded first. So literally just by flipping that to be a foreground image, suddenly the browser recognizes, oh, that's higher up in the code, and I can see that it's a foreground image, so I'm going to kick that off downloading, and then these things can come in further down the line. We should also be serving appropriate sizes. You know, browsers, devices vary, you know, different pixel ratios and all that kind of stuff. It's fairly straightforward to do these days. We have source set for that. It's progressive enhancement again, almost 90% support, so pretty much every browser supports this stuff these days. And you can just define for different widths or different densities which file to download. Obviously, you might need some form of transformation tool there, so again, you need to see what's kind of available in your stack. But also, we should be looking at the actual appropriate formats as well. There's more optimized formats than just serving JPEGs to everybody. So it gets a little tricky though. So there's JPEG 2000, which only Safari supports. Then we've got JPEG XR, which only IE and Edge support. And then we've got WebP, which currently only Blink-based Chrome or Opera browsers support. The reason why I put this last is that the next version of Edge will have support for WebP, and Firefox have announced that they're putting it in early next year as well, so this is going to get a lot better. So there's all these different formats that we can output, and the traditional way of kind of choosing which one to send to a user is to look at the header that gets sent from browsers. So browsers will say, look, preferably give me a WebP, if not, fall back to just any old image. This is even when requesting a JPEG. So we don't really want to be tinkering with the server side of how we deliver this. You can do this entirely in the client side though. So the good old picture tag, which has, again, great support now, complete progressive enhancement, so it'll just be ignored if it's not supported. In here you can put in different sources and give them the MIME types, so the browser will pick the most optimal format for whatever it supports. This is where our source set comes in, so again you've got the different image files and their different widths, and then ultimately it just falls back to this image tag with a source attribute, so you can have a fallback there as your kind of old school desktop machine for like IE 9 to 11, I guess. So that's a fairly straightforward format these days. And then the final thing for images is just lazy loading beneath the fold. So you didn't see this on the kind of video, but beneath the kind of viewport I had some further images. For some reason I chose to put watches down there. And they're not within that view, so we don't necessarily need to load them. Now, for these two we might, because they're pretty close to the fold, but you want that kind of distance ahead. But generally we just don't want to be wasting people's bandwidth if they never scroll down. So there's a whole variety of ways you can do this with JavaScript. You can even get really advanced and use the kind of medium method where they do the kind of blurred image, load a really low res version that it's like half a kilobyte, and then only when people scroll down they load the full one. So that's kind of a fairly straightforward thing to implement. Obviously you need some sort of transformation to blur the image, but things like JPEGs compress really, really well when you do that. So the results of our image optimizations were actually quite astounding. I didn't expect our start render times to improve. Clearly we unblocked a bit of the network so things could load a lot quicker. But the main one was our bandwidth. We were using 2.5 megabytes of data, and now we're only using 300 kilobytes. And it's a lot more reasonable for those people on kind of CAT data plans. And again, a load of money. So I could ramble on a lot more about images, but there's an awesome website just called images.guide. It's sponsored by Google and Imagix and other transformation companies. So I recommend checking that out. So if I combine all of these things together, where do we get to? So we've chopped almost 4 seconds off that start render time. Speed indexes are like a third of what it used to be. We've chopped 2 seconds off the time to interactive with our JavaScript and being able to interact with that page, and the bandwidth's gone through the floor as well. So a lot of money for big companies. And again, I've got the video to kind of give that more real view of how it actually looks. So if you look at the one on the right hand side, because this one's going to take far longer, I'll start that going. And you can see that in just over 2 seconds we start to see something on the page, and it actually completes rendering and loading before this one has even shown anything. So it's kind of a stark difference between the two. So to kind of summarize, there's a lot of low-hanging fruit when it comes to performance. You know, a lot of what I've shown today, some things are a little more tricky, but some things are very, very straightforward, like reordering your head tag. You know, you're not changing any content, you just literally have to, you know, move a few lines around, so it's fairly straightforward. So you're gonna have immense impact with this. And I know I'm running over time, but I do have one little bonus point for you, and I promise it's quick. So I haven't talked about service workers yet. They have excellent support now. It's a requirement for things like PWAs or progressive web apps. And yeah, 80% of browsers, again, this is one that's just gone through the roof in terms of support this year. Progressive enhancements, so others ignore it. There's a whole bunch of fancy stuff you can do with them, like offline support, how you download files, and you could use stale ones that are sat in your cache. But this is the main thing that you can use it. The exciting thing for me is that if you can't do any of these optimizations, if you have third parties on your site that would block render or effectively take your site down if they had an outage or a slowdown, what you can do is force a timeout on those. So rather than waiting that 90-second for browsers to time out, if you implement just this amount of JavaScript code into a service worker, you can set a timeout, and it basically uses a promise to race the timeout against actually downloading that request. So I've set this to 2000 milliseconds. You can configure it to whatever, and I've just set it so that it only does it on example.com requests. So you could put your third-party particular hosts in there, or even exact URL. So you could say, if this file that blocks us takes longer than a few seconds to load, just don't bother trying to load it, and then allow the site to render without it. So this is great for things like A/B testing tools or personalization, where it's like, if it loads slow, I'd rather have the user able to browse the site than just not even see any stats from them or have them just bounce away. So that's all I've got for you. Thank you very much. That's the link to the slides if you want them, and I'm going to be around for questions.
All right, thank you very much, Ryan. So we've got some pizzas at the back. We're going to have a break now for